Okay, we're going to learn how to work with logarithms a little bit by looking at the properties of logarithms. Okay, now the properties of logarithms all come from corresponding properties of exponents. So if you'll notice over here I've listed properties of exponents. You may be a little confused by this one, but it's a matter of perspective. Are you looking at the whole or as pieces applied to each other? And now we're going to look at what they turn into when we turn them into logarithms. So a to the 0 equals 1 no matter what a is means that log base a of 1 equals 0 no matter what a is. A to the 1 equals a no matter what a is means that log base a of a equals 1 no matter what a is. If you remember, these corresponded to those two special points on every exponential or every logarithmic graph. Now, if we have things of the same base, we can add the exponents. Corresponds with if we have a multiplication inside a logarithm, it will turn into an addition outside. Okay. Now, this is where the warning up there comes in. Warning number 20 is that they do not work backwards. Meaning, here I have multiplication inside turns to addition outside. It is not true that addition inside would turn to multiplication outside. In fact, addition inside a log, there's absolutely nothing you can do with it. You just have to leave it alone. Now, properties of exponents, when we're dividing, we turn to subtraction. So the corresponding property of logs, okay, when we're dividing inside, turns to subtraction outside. And then lastly, this weird one that's a matter of perspective. When you rewrite it as logarithms, okay, it says that log base a of a to the x is x. Now we already knew that, but what you can actually do with this is say, well, also log base a of b to the x, where the bases don't match. Well, the logarithm and the exponential will not cancel each other, but it is true that you can bring this exponent down in front of the logarithm. Now, our last so-called property of logs is called the change of base formula. And the reason we need the change of base formula is to be able to use a calculator. Because if you pull out your calculator, at most, you'll have two logarithm buttons. You might have just log, which is log base 10, and you definitely have ln, which is natural log. But what if I want the log base 7 of 3? I don't have a log base 7 button on my calculator. So what you can do is we're going to use the change of base formula to turn it into whatever base we want, typically a natural log, but it will work with any base. So I start with just a regular old logarithm. I choose a new base, say base c, that I want to turn it into, and it's going to turn into a division of logs. So on top it's going to be log base c of that b, and on bottom it's going to be log base c of that a. Notice it's positional. The b was above the a, the b is above the a. Okay, now we're going to do two examples using properties of logs, and they seem backwards because one will undo what the other one did. Okay. And there's different examples of when you would need either one. So firstly, we start with a very condensed logarithm, okay, and I want to break it apart into logarithms of simple things. Meaning I don't want exponents, products, or divisions inside the logarithm. So, in this case, I'm going to be moving left to right on my properties of logs. Okay. So, I notice that the very first thing about inside of the logarithm is the square root. And a square root is really a 1/2 exponent. So I could think of it as this. And I go through, and the main three properties we're going to be looking at are these three. And I notice that this one right here tells me that exponents can be brought in front. So that 1/2 is going to be brought in front of the logarithm. Now the next thing I notice is that inside the logarithm I have a division. So I go over here and say, well, division becomes subtraction. There's one little thing you have to be careful of. Because the 1/2 was in front of the log before I turned the division into subtraction, both pieces are going to get that 1/2 when I turn it into subtraction. Okay? And now I look at this one and I say, well, that's a product inside, so it becomes an addition. And again, this minus 1/2, both pieces are going to get it. So I get 1/2 ln of x to the 6th minus 1/2 ln of y to the 5th minus 1/2 ln of z to the 8th. Notice, everything that was on top in the original is positive in front of it, and everything that was on bottom in the original is negative in front of it. And the very last step is to use this one again, which is to bring down those exponents in front. So I bring down the 6, and 6 times 1/2 is just 3 ln of x, minus, I bring down the 5, and I get 5/2 ln of y, minus, I bring down the 8, and I get 4 ln of z. And these are simple logarithms. The things inside them are as simple as possible. Now, another type of problem we can do does the opposite, meaning it starts with simpler logarithms and I want to be able to write it as a single logarithm. So I'm going to be using the same 3 properties but in reverse. So instead of starting with the left and turning to the right, I'm going to start with the right and turn to the left. Okay. Now, we have to work from the inside out, and there's one thing you have to know. If I look at this and I see the addition and I want to be able to combine it, I can't do it right now because the logarithms don't have the same number in front of them. So, in order to be able to combine things that were added or subtracted into multiplication and division, I have to have nothing in front of the logarithms first. So I'm going to use this property first. So this 5 is going to come up as an exponent. I'm going to leave that 3 for now because of the bracket next to it. This 7 is going to come up as an exponent, and this 4 is going to come up as an exponent. Now, just as a side note, square root of z to the 4th, well, that just is really z squared. There's no reason to make it more complicated than it has to be. Okay, now I can combine this addition into a multiplication inside a single logarithm. Okay, now before I can deal with the subtraction, I need to get rid of this 3. So it comes up as an exponent. Okay, and now that there's nothing in front of either of the logarithms, I can combine this into a single division. And I get this written as a single logarithm.